So we're talking about excavations. We are in the OSHA manual, 1926.651. It's actually 1926.650 and then .651. And then where we're going to start reading, you'll have to flip over a couple of pages. I want you to find Appendix A. We're going to be talking about the different soil classifications at first. You will also find a summary, kind of a synopsis of this information in the contractor's manual. I believe it's on page 7-47. It's where they, in that chapter 7, where they first start talking about excavations, they talk about, and then they talk about ropes and rigging. Well, they talk about excavations for a couple of pages first. Okay, so excavations can be dangerous because excavations can cave in, right? So there are some requirements with regard to sloping the sides of an excavation. Okay. And you can't, unless it's in stable rock, you can't dig an excavation deeper than 4 feet without doing something to prevent a cave in. Okay. You can put a trench shield in there if you want to, but absent a trench shield, you've got to do some sloping. You're going to have to slope each side. Okay, well, what slope do you use? Well, it depends. It depends on what type of soil it is. All right. If it is a thick soil like a clay and it's very cohesive and it's not very likely to cave in, well, then there's a different requirement than if it is a sandy soil, which is very likely to cave in. And there's actually three categories, okay, of your types of soils, and they call them type A, B, and C. So where I'm going to be reading from is section 1926, okay, 650, 651, 652. This is subpart P, excavations, all right, and under in the appendix A, all right, there is a section that says it's titled soil classification. All right, so here we go. I want you to find, it's all in alphabetical order, and I want you to find type A. Type A means a cohesive soil with an unconfined compressive strength of 1.5 tons per square foot. Sometimes they can just ask you that. Okay, and you're done, or greater. Examples of cohesive soils are clay, silty clay, sandy clay, clay loam, and in some places silty clay loam. So you see what we're talking about here? We're talking about that clay I mentioned a minute ago. Okay, if you've ever dealt with clay, you know clay sticks together. Clay is not really all that likely to cave in. So there is a different requirement for clay. All right, so than there is for other dirts. All right, so that's clay. All right, and tells us all about the soil classification. We're not going to talk about the sloping and benching until after we talk about the different types of soils. Then they have something called a type B soil. A type B soil means a cohesive soil with an unconfined compressive strength greater than 0.5 ton per square foot, but less than 1.5 tons per square foot. Okay, so it's not as cohesive as the clay. Granular cohesion-less soils, including angular gravel, crushed rock, silt. Okay, so here's where we come up with the term loam, L-O-A-M. I never heard that term until I actually was sitting where you are in a class trying to pass my first contractor's exam. Okay, so we're talking loam, silt loam, sandy loam, in some cases silty clay loam and sandy clay loam. Well, what is loam? Well, I would like you just to think of loam as dirt. Okay, just everyday ordinary dirt. All right, so that's a type B soil. Okay, so you can find that. They could just ask you about the B soil, or you might have to do an excavate. You might have to do a calculation actually. Okay. So type C is a cohesive soil with an unconfined compressive strength of 0.5 ton per square foot or less. Okay, 0.5 ton, type C. Granular soils including gravel, sand, and loamy sand, or, and then it talks about some more, but basically what we're talking about is sand. If you've ever walked along the beach, you know that sand will cave in as soon as you take your foot up. As you're walking, sand will cave right back into your footstep. Okay, so it is going to cave in rather readily. And so you need to understand the difference. There's a different sloping or benching requirement, as they call it. All right, so as you go to the next page, as you flip over to Appendix B, which should be just another page, further back in the book, Appendix B says sloping and benching. It's titled sloping and benching. And we got a table there. Okay, so it says if it's stable rock, you can have a vertical side. Okay, that's fine. 90 degrees. If it's in type A soil, which is clay, all right, it is 3/4 to 1. Okay, 3/4 to 1. So what does that mean? If the first number, by the way, the 3/4 is your horizontal. That's your horizontal measurement. The 1 is your vertical. It's HV, and that's what it tells you at the top of the table. It's H to V. That's a ratio. Okay, so if the 3/4 is your horizontal and the 1 is your vertical, so tell me this: if we were in a 10-foot deep excavation, okay, 10 foot deep, what would be the horizontal requirement? How far horizontally would the top of the slope have to be?
You just divide it 3/4 by 1.
No,
That
but
doesn't
if it was 10 feet deep,
Mhm. So for every foot, it's 3/4 of a foot.
exactly, for every foot vertical, it's going to be 3/4 of a foot horizontally.
So divided by 10.
It's going to be 3/4
Divided by 10
times 10.
times 10.
Yeah.
Oh, I got you. 7.5.
7.5. Okay. So you're 10 foot deep. Since this is a relatively cohesive soil, okay, you got to slope it out. Okay. So if you're 10 feet deep, you've got to slope it out 7.5 feet at the top. So you're going to have what they call a 53-degree slope on a type A soil. Okay. Now you get into this loam they talk about, which is a type B soil. Okay. Now type B soil is 1-to-1. So a 10-foot deep trench or excavation, a 10-foot deep excavation would have to go horizontally how many feet? Horizontally how many feet?
10 feet.
10 feet horizontal, 1-to-1. 10 deep, 10 horizontal. All right. So that would be 10 feet deep, 10 foot horizontal. Now a type C soil, which is going to be sandy, very likely to cave in. If you're going to go 10 feet deep, then you have to go how far out horizontally at the top? 1.5 to 1. So the answer would be
15.
15. Yes. 15 feet horizontally for 10 feet deep. So now there's so this is where this whole concept begins. All right. What it does get a little more complicated, because if you go below the table, you'll see a set of figures. It says figure B1, slope configurations. All right. B1.1, excavations made in type A soil. All right, type A soil. Okay, so a simple slope in type A is 3/4 to 1. That's what that top left diagram shows us. Okay. But it also says in a short-term slope, we don't have to go 3/4 to 1 as long as it's a maximum of 12 feet deep. What does it tell us there in that other diagram to the right?
1.5 to 1.
One half to 1. So you don't got to go quite as wide if it's only going to be a short-term simple slope that's 12 feet or less deep. So there's some variation there. So they make a little allowance for the fact that it's not more than 12 feet deep and it's short-term. I think they say 24 hours. That's what they mean by short-term. Anything less than 24 hours. Now there's another one even more important than that diagram. I want you to drop down to where you've got one that's got like a little squared off section at the bottom. If you think about maybe somebody laying culvert or pipe, maybe they would have a squared off section at the bottom. And that's what I want you to find, the one that says, underneath the diagram, it says unsupported, vertically sided lower portion, maximum 12 feet in depth. Okay, so there's a section at the bottom of this slope that's 3.5 feet tall max. Okay, and then the whole excavation, it says, is 12-foot maximum. Okay, so it's got to be less than 12 feet, 12 feet or less, and you can have this unsupported vertical sided portion at the bottom that's 3.5 feet tall. But the rest of the slope, the rest of the trench has to be sloped at what ratio?
1 to 1.
1 to 1. Exactly. So you're right. You obviously or have found the one that I'm talking about. Okay, so it's 1 to 1. So while these general guidelines we talked about at first are important, it does get more complicated. And then, or you can use a trench shield. And this is a question that I have seen before. If you're using a trench shield, the trench shield has to extend up above that vertical side. How far?
Minimum of 18 inches.
18 inches. That's what that bottom diagram says. Okay, so these are the types of things that you may be asked. There's some other diagrams. There's some diagrams for type B soil. There's some diagrams for type C soil. So just kind of keep those in mind. Just kind of keep those in mind right there. So that's basically an overview. That's of the sloping and benching. Now a couple of little things that we need to make sure that we understand. If we look back on that table, it does tell us that this is a requirement for excavations that are less than 20 feet in depth. Once you get to 20 feet and deeper, they want you to use an engineer, okay, to draw it up. And then there's another requirement there about your sloping and benching. It's only for excavations that are a certain number of feet or deeper. Let's see if we can find that. Okay, let's look at 1926.652. 1926.652 requirements for protective systems. And each employee in an excavation shall be protected from cave-ins by adequate protective system designed in accordance with this chapter. And 2I says excavations are less than 5 feet in depth An examination of the ground by a competent person provides no indication of a potential cave-in. So that's that. So the requirement for the benching and the sloping begins at 5 feet. Okay, that's what paragraph 1926.652 A1 double I tells us. Okay, now they give us, it's a little bit, it can be a little bit confusing because there is a 4-foot threshold that we have to address in the same chapter. It's in on the previous page or so. Now this is in 1926.651, and it's paragraph C as in Charlie, C2. Okay.
One more time, please.
Yep, 1926.651 C2.
Got it.
Okay, does anybody have a page number for us on that?
326 in mine.
326. Okay, very good. Okay, so we're in C2. So now this gets a little tricky. So means of egress from trench excavations. Means of egress basically means a ladder, right? You got to have a ladder. You got to have a way for people to get out of that trench. A stairway, a ladder, ramp, or other safe means of egress shall be located in trench excavations that are 4 feet or more in depth so as to require no more than 25 feet of lateral travel. Okay, so a person cannot have to travel in a trench that's 4 feet or more, okay, to the first means of egress. All right. So my question is, how far apart do the ladders have to be? And it's kind of a trick question.
25 feet from each other.
Okay, so you're saying that the ladders have to be 25 feet apart?
From each other, yes.
Yeah, and that is, at first glance, that would be the answer. Okay, but it's a little more complicated than that. How far apart do the ladders have to be?
Am I looking at the right thing? Where is more than one ladder?
Okay,
So are we talking multiple levels?
no. What paragraph are you reading now to?
E2 means of egress from trench excavations.
Right, so what we're talking about a long trench. Okay, okay, you're in a long trench. You have to have a ladder every so many
Every
feet.
25 feet, but you're
Okay.
saying that's not the answer.
I'm saying that's not the answer.
Okay.
So I want somebody to think a little more critically and tell me how far apart those ladders have to be.
We're on C2 still?
Yes.
That are 4 feet or more in depth.
This is almost one of those brain teasers that they tell you in school. You got a farmer and a chicken and a bag of feed and a and you're trying to get them all across the creek without the fox eating the chicken and the chicken eating the food, the corn. Remember that one?
So the egress, is that the length of travel right there?
Egress just means, egress is a fancy word for a way to get out of the trench. Egress means get out. Egress is sort of like a window is a means of egress from a building. A door is a means of egress from a building. A ladder is a means of egress from a trench. But at first glance, you would think you would need a ladder every 25 feet, but that's not the case.
Oh, I have no idea.
Okay, think about this. You have to read the wording very carefully. It says,
I can't read.
it says that a person can't have to travel more than 25 feet to a ladder, right? So I want you to picture a little diagram
Oh,
where you have,
21 feet.
50.
it's 50 feet because you got a person in the
Yeah,
middle
that's
of,
right. Yeah.
yeah. If you got a person in the middle of two ladders that are 50 feet apart, that meets the requirement. Then they don't have to
gotcha.
travel more than 25 feet to either ladder.
Oh, that's a dirty question. Are they
It
gonna give us?
is.
Yeah.
Yes, absolutely. Absolutely. So if they tell you it's 100-foot trench, how many ladders do you need? You need one every, you need two. It's
Yeah.
every 50, it's every 50 feet. However long the trench is, divide it by 50, and you'll
They
get the
did me
number.
dirty today. I got a 68.33 on my financial.
Oh, no. 68.33. Holy moly. Oh, boy. How did the math go? Was there any of those
Yeah, there was actually a lot of math, a lot of unemployment, a lot of 455. I think I got the hardest test possible today.
455? How comfortable are you with that business math?
I was doing pretty good for about 2-3 hours, and then I saw the time clicking down, and I just I should have took a break, and then towards the end I was kind of scoping through all this stuff, and then I think I missed like 5 questions where I didn't answer, so I think that's where it got me. But yeah. It was just mostly the 455 and the 201, 701, and 401, and the unemployment that got me. A lot.
Okay.
There was a lot of that.
How comfortable are you with the percentage of completion problems and that type of thing?
When I'm able to read it, I think I'm pretty good about it, but there's so much to just memorize. I try not to do that. I just try to kind of, like you're saying, is go through the books and just know where it's at.
Because usually for somebody that is really close, really just really close to the edge of passing, usually if we spend a couple hours in a tutoring session doing some math questions, that's enough to bump you over the top. But because it's the math.
Yeah, no, it was definitely the math that got me, because I found myself looking at one and I looked over and it was about 10-15 minutes that passed by, and it was pretty quick.
Yeah. That'll happen. That'll happen for sure. Okay. Well, wish you the best on the next time around. You can go, a lot of people don't know this, that you can review your exam. Yeah. And I encourage people to do that, because at 68.33, for the first time ever, I talked to somebody who challenged his a question, because he was only one question shy, and he challenged and he won, and he did win the challenge. That was the first time I ever heard that happening, but he did do that, so it is a possibility.
That's not my luck.
Well, I've never, from the time I started teaching back in 2005, these exams, I was always told, don't waste your time contesting. But it has happened where somebody has prevailed in that.
Yeah, I'm just gonna buckle down on the A1As and the 455. I think that's, if I could get that, because I got